Hello everyone, my name is Jang-Seok Kim, doctoral candidate student majoring in mechanical engineering. In this semester, we cannot meet on offline class because of COVID-19. It is very regretful. Today, I will present to you about implementation of scan matching using ICP algorithm. ICP means that iterative closest points. It is very simple and widely used on many kinds of technical fields, such as SLAM, as we know, image processing, and other graphical technique, and so on. These are fundamental steps to implement ICP algorithm. In this page, I will present a whole step briefly. Before start, we need two given data set. One is measure data P and other thing is reference data Q. At first, we have to compute the correspondence of two data and mean values of each data set P and Q. From this computation, we can know that how many difference pose between data P and Q. Pose means that angle and distance between two data. And we can know some values which can reach to reference data. After compute values, we update measure data using that values, and then check error between data P and Q. If error is larger than expected accurate values, repeat the previous step until error is become small sufficiently. The first step is compute correspondence between given two data sets. From all of points in measured data set P, calculate the distance to all of points in reference data Q. People calculate the distance in these two data sets have none data. None is not a number, so we have to ignore these none values. After calculate the distance, save the information of nearest point, index of P and index of Q and distance in variable called correspondence maybe. It is the same as 3 by n matrix or array variable. As you can see, this is a correspondence variable. It contains a index of P, it contains index of closest data of Q, and distance between P and Q. As you can see, this is a MATLAB code. And then, for getting more exact correspondence result, we compare the each values which has the same index of Q. As you can see, the index 1 of P has the nearest point information, index 1 of Q, like this. 1 has a 1 of Q. And index 2 of P also has the same point information, index 1 of Q, like this. So we have to remove the information which has the further distance than others. It is further than this, so we have to remove this information. This is a MATLAB code. In second step, compute cross-covariance matrix and mean values of each P and Q. Cross-covariance matrix show that how much distribute to data P and Q is. Cross-covariance matrix can compute by summation of all multiplied data P and Q. In this calculation, we have to multiply data based on correspondence information computed before step. And also, we can compute mean values of P and Q by summation of all elements and divide by n. N is number of elements which has a correspondence information. Third step is find the rotation and translation values from cross-covariance matrix K and mean values. From matrix K, we can get the rotation matrix easily using singular value decomposition, SVD. SVD is a famous theory in linear algebra and matrix operation. It means the matrix has each singular values having characteristic information of a set. As a result, we can get rotation matrix R like this. And then from mean values of each P and Q, we can find how many distance P and Q is. It is a T, like this. Easily saying, when we play with a puzzle or assemble some toys block, we rotate as much as the whole procedure and move the object to there. Like this work, we repeat the same sequence to feed it until error is become smaller than threshold value. This is error equation. We have to repeat previous step before error is become smaller than threshold values. Finally, I implement ICP algorithm to 4 dataset professor gave us. The first result, after 16 times iteration, RMS error becomes 15, about 15.4. It is lesser than 50. 50 is a given threshold values. The second result, after 17 times iteration, RMS error becomes about 5.7. It is also less than 50 given threshold values. The third result, after 56 times iteration, RMS error becomes about 21. It is also less than 50 given threshold values, but it takes longer time than previous two cases because it contains rotational changing, I think. The final first result, after 16 two times iteration, RMS error becomes about 16.6, about 16.6. It is also less than 50 given the threshold values. It also takes a longer time than previous first and second case because it contains a rotational changing. I found several references by Google searching like this. Thank you for watching and have a good vacation. Thank you.